All right, so today we're going to talk about graphing rational functions. So remember, rational functions are the fraction type of problems that we've been dealing with in this chapter, and now we're going to look at the graphs of them. Your basic rational function is this right here, y equals 1 over x. It's a fraction problem, usually, x in the denominator. So when you have a rational function, a couple things to know about this. There are some values that are just not allowed. Now, you guys know that you never can have a 0 in the denominator of a fraction. So in this case right here, in this problem, y equals 1 over x could never be 0 because 1 over 0 is undefined and we can't do that. So we're going to talk about that a little bit later, but let's go ahead and see how this graph over here on the right comes to be. So let me go to the next page for that, a little bigger. So back in Algebra 1, when you used to, learn how to graph things, you would make a table, right? You'd have your x values that you chose and then your output, your y values. And in this case, y equals 1 over x. So let's see what happens. So let's try x equals 2, let's say. I plug in 2, so that means I'm going to be plugging in a 2 right here. So plug in 2, I get 1 over 2. So 2 and 1/2. That's a point. So look, here it is, 2 and then 1/2. There's a point on the graph. If I do something like 6, so I plug in 6, I get 1/6. So 6 and 1/6, there's that point. So it might seem, then they're pretty obvious. So as you get larger and larger, if I picked something like 8, I would get 1/8. And so you see the values are getting smaller and smaller and smaller. So what's happening here is as you go to the right, the graph is getting lower and lower and lower. It's never going to be negative, but it's going to be almost 0. Like if you plugged in 100, you get 1 over 100. So it's something really small. All right. Now these values on the left-hand side, same thing would happen if you plugged in, -3 right here, you get -1/3. If you plugged in -6, you get -1/6. And so it's the same values on the left-hand side, just kind of, similar idea. But let's talk about numbers that are smaller than 1. So let's talk about why this graph kind of rises up really, really fast right here, really high. So let's try a number like, inside right here in this little area there, like why is it getting bigger and bigger and bigger? So let's try like 1/2, let's say. So if I plug in 1/2, so remember I'm plugging 1/2 into this piece right here. So this would be 1 over 1/2, which means it's 1 divided by 1/2, which means it's 1 times 2 over 1, so that's 2. So 1/2, the answer is 2. So there we go, 1/2 and 2, there's the point. All right, so let's try a number like, how about 1/5? So that'd be 1 over 1/5, which would eventually come to 1 times 5 over 1, so that'd be 5. So 1/5 is 5. All right, so you can see as we start to get numbers that are really small, as I start to get numbers closer and closer to 0, my answers get higher and higher and higher, okay? Because I can't plug in 0. This is a big no-no right here, right? So if I try to plug in 0, I would get 1 over 0, which is undefined. And so that creates something called a vertical asymptote right here. So on this graph, you have a place that you cannot go, all right? And that's called a vertical asymptote. An asymptote is a new word for you, but there's this place right here, x equals 0. You can't use it. You cannot plug 0 into this problem. So that creates something called a vertical asymptote. So it's kind of a weird word, but it's a math word, a vertical asymptote. All right, so there's also something on here called a horizontal asymptote. Now, a horizontal asymptote is a horizontal line that it's not necessarily that you can't cross it, it's just what your graph goes to. So y equals 0 is your horizontal asymptote. Right? And you don't have to write these things down. I just want you to watch and pay attention, okay? All right, and so the horizontal asymptote, there's different ways, there's different rules for finding those, so we're not going to talk about those as much today, but we're just going to talk about how this graph moves around and how these asymptotes change. All right, so I want you to remember back to when we did things like this, like when we had your basic parabola, right? Basic parabola graph, looks like a U shape, y equals x squared. Remember that we would move it around, right? So if we had y equals, we'd have like x minus 3 squared plus 4. So when we did that, we'd be like, oh, this moves it to the right 3, and this moves it up 4. We've done that recently. So if I had a graph, that same parabola, I said to myself, oh, it has to move to the right 3 and up 1, 2, 3, 4. So here's a new vertex, and then there's the new parabola, right? And so it would just be a transformation. Well, the same thing happens to our rational functions. When we have y equals 1 over x, if I were to change that to y equals 1 over x, let's say we put minus 3 and plus 4, that would do the same thing to the graph. It would move this to the right 3 and it move it up 4. And so remember, my original graph of my rational function looks like this. It's a little curve on one side, curve over here. I know it's kind of ugly, but basically my graph would shift around, and that's what we're going to practice doing. And so my asymptotes would move as well. All right, so let's go to the next one where I have one drawn here for us. So let's see. Y equals 1 over, let's do x minus 2, and how about plus 1? All right, actually, you know what? Let's just do x minus 2 for now. All right, so y equals x minus 2. So that means that my graph moves 2 to the right. So my graph moves 2 right. Okay, so my asymptote used to be here at x equals 0. That's going to be now moved over 2 to the right. So here's my asymptote now. My vertical asymptote is at x equals 2, because it used to be at 0, but now it's moved to the right 2. My horizontal asymptote is still at y equals 0, because it didn't change at all. Nothing moved up or down, so y equals 0, my horizontal asymptote. This is my vertical asymptote. All right, so this graph now has to move along with it. So I'm going to try to move it here. Let me grab that. This moves over 2. Let me grab this part. And this moves to the right 2 as well. And that would be the new graph. All right, so now let's go ahead and do this one. Let's say we had y equals 1 over x plus 3 and minus 1. Let's make that a minus 1, that's fine. All right, so x plus 3 is going to take my vertical asymptote and move it to the left 3, and this is going to move me down 1. So my vertical asymptote used to be at x equals 0, but now it's moved over to the left 3. So it's right here. So x equals negative 3 is my vertical asymptote. My horizontal asymptote used to be at y equals 0, right here, but now it's at down 1 from that. So now it's down here at negative 1. So my horizontal asymptote is at y equals negative 1. And my graph moves accordingly. So my graph right here, the blue graph, is going to move left 3 and down 1. And same thing for this guy over here. It's going to move left 3 and down 1. Okay, because 2 parts to the graph. Like there's 2 sections to it, so they both have to, if I could move them both at the same time, I would, but I can't. All right. So let's take a look at one more of those. And let's take a look at if we had y equals 1 over x minus 4. And let's do a minus 2. All right, so this graph moves to the right 4, and it moves down 2. Now remember, this also has to do with the domain. Remember that in these fraction problems, we have restricted values, right? So when I look at this fraction right here, I would tell you, hey, you can never let x be 4, because if x were 4, I would get 1 over 4 minus 4, which means I have 1 over 0, which is a big no-no, right? So this restricted number is also where your vertical asymptote is. So 1, 2, 3, 4, there it is. So there's my vertical asymptote. So vertical asymptote is at x equals 4. And then down 2, so my horizontal asymptote is at negative 2. Y equals negative 2. So my graph accordingly moves to the right 4, and down 2. Just grab this guy, right 4, down 2. Okay, all right. And we can graph this without having our original picture there. So if I wanted to go ahead and just graph one on the fly, I'd say y equals 1 over, let's say we had x and then plus 5. So if I had this, the 1 over x means I would have the same vertical asymptote. It didn't move right or left, so the vertical asymptote would still be at x equals 0. But the horizontal asymptote moved up 5, so 1, 2, 3, 4, 5. Y equals 5. Okay, so my graph would be here in this corner and here in this corner. Now, you can the graphs the blue parts do not have to be where they are. I mean, it could be flipped over. They could both be up top or both on bottom. Those are just different types of pictures that you'll see. But for now, we're just doing the basics. All right, so let's just do one more of these. And let's say we had y equals negative 1 over x plus 2. And let's do a minus 1 over here. How about minus 4, actually? All right, so 3 things happen to this. This negative up here, remember, that causes a reflection. Reflection over the x-axis. And then the plus 2 causes a left 2. And the minus 4 causes down 4. Now, this piece right here, remember, is a super important piece. This is telling you your domain. This is telling you what your restricted values. So remember that x cannot be negative 2. That is a bad thing because that would create a 0 in the denominator. So it also tells you your vertical asymptote is at negative 2. So move left 2, down 4. All right. And then the reflection. So normally I would draw the graph right here and right here, but now it's going to be reflected. So this piece right here gets flipped over down to the bottom. So it is going to be down below. And I would have drawn something in this area here. I would have done this, but now it's going to be flipped up here. So there it is up there. And I'm just kind of like freehanding these things, but you know, you would go to Desmos and you could graph these a little bit nicer. Okay, all right, so let's take a look at Desmos and see that a little bit. So you can see I have, if I have my basic graph, you know, this one right here, 1 over x minus 2 plus 4, I can graph x equals 2 and y equals 4. Those are my asymptotes, and it looks like they, you know, line up very well. And so, you know, you can see they move them around until they fit right where they're supposed to be, or here, you can see how they fit there. Okay, and if you want to change that, let's say we had this x, let's say it was x plus 1, and then it was a plus 3 on the outside. So now my asymptote should be at negative 3. X equals negative 3. I'm sorry, negative 1, because of the 1 on the bottom. And the y asymptote, the horizontal asymptote should be y equals 3. Oh, there it goes. Okay. All right, so you can graph those on Desmos as well. All right, and that is all. We'll see you in class. Bye-bye.